Bright Tuty. Every student matters.
Hello students, today in this lesson we are going to learn about three-dimensional shapes. Here are some pictures that you might observe around you. A ball, a can, a hat. Anything that you can hold in your hand is called as a three-dimensional shape. Since we are learning this lesson of understanding elementary shapes, so far we have just covered two-dimensional shapes that were flat. Now this lesson in this lesson we will learn something about three-dimensional shapes. So everything that you see around you which you can hold in your hand is a three-dimensional shape. Now let's see some of the common three-dimensional figures that we will learn about. Here starting with the cone. So the solid shapes which are having three-dimensional, we call them 3D. It's a short form, the D, capital D. We use this for the word dimensional. Okay. So starting with cone. What is a cone? As in you see in an ice cream cone, this kind of a structure refers to a cone which is a three-dimensional shape. So here in a cone, we see we have got a circular plate, and then at the bottom we see this kind of a structure which is like you have folded out something which is forming a one end which is a tip, and then you have the circular boundary here. So you can try making this by cutting out a triangle with the help of a paper, and when you roll this triangle, this particular kind of a structure is formed. It's simple to imagine a cone by thinking about an ice cream cone, right? So this is one of the three-dimensional shape. Now moving to the next one is a cone. It's a cube. Cube you might have seen very commonly while playing Ludo. You might have seen the cube there you play with, the dice that you roll. It is an example of a cube. So if you see a block, children play with small blocks. So these blocks, they are in shape of a cube. So it is a three-dimensional shape. Sometimes they ask you to try drawing this three-dimensional shape. So how do we draw squares? So we draw a cube by drawing two squares like this. I'm sorry, these are not exactly the same in size. However, they need to be exactly same in size, and then we join each of the vertices like this. So this is some kind of a 3D that I've tried. However, it's not accurate in the measures. Now coming to cuboid. Thinking of cuboid, you can think of a matchbox. So how it is formed? It is formed when we have a rectangular surface. Like the cube, it is made up of square surface. Okay, all the faces that a cube has got, it has got square faces. Coming to cuboid, cuboid has got rectangular faces. So this is a cuboid, and if we just join all these vertices, these faces together, this is the kind of a shape that is observed, and this cuboid is similar to a matchbox that you can think of, or even the pencil box that you have with you. Every such kind of shapes are usually in cuboid shape. Now moving to the next image. Here, this is an image of a glass tumbler that you have. This shape is called a cylinder. Let's think of any other example of cylinder. Say the road roller that you see. So the roller that is attached to the road roller, that is also in the shape of a cylinder. So how is it formed? You have two circular faces at the top and the bottom, and you just join these two faces. This is a rough sketch I have made of a cylinder. Okay. Now comes sphere. Sphere, a very simple example of sphere is a ball. Also Earth, then all the planets that you know about, all such shapes that looks like a circle, and they are 3D in image, so they are called as a sphere. Okay, and now coming to pyramid. What is a pyramid? As the pyramid of Giza, the example. So here, this is a Rubik's of pyramid shape. Rubik's cubes are very common. There are also Rubik's that are in the shape of pyramids. And also the pyramids that are seen in Egypt. So they are also the example.
Look at the animation.
Pyramid. A pyramid is a solid with side edges meeting in a vertex. All of its side faces are triangles. A pyramid is named according to the shape of its base. Triangular pyramid. A pyramid with a triangle as a base is called a triangular pyramid. It has 4 faces. It is also called a tetrahedron. It has 6 edges. It has 4 vertices. Square pyramid. A square pyramid has a square as its base. It has 5 faces. It has 8 edges. It has 5 vertices.
What are the faces, edges and vertices in these 3D images? Okay, so starting with cuboid, right? All the flat surfaces of the solid shape are called the faces of that figure. So here what do you see? We have got this particular cuboid, and you see that the top they have colored it, and this solid filled colored top we call it a face. So how many faces do you see in this cuboid? Count all the faces that you see. So one at the top, one will be at the bottom, then 2 on each of the sides, then 2 over here, and from there as well. So total how many sides do we have? 1, 2, 3, 4, 5 and 6. So total number of faces in a cuboid are 6. Now coming to the edges. What are edges? The line segment where 2 faces meet each other are called edges. See here where you see that this particular face, I'll just use, okay. So this particular face that you see and this particular face that you see, these 2 faces are meeting each other at this particular line here. This particular edge, this particular the meeting point of these 2 faces is called an edge. So how many total edges do you see? Here this particular face, the top one, and this right side face, they are meeting each other at this particular edge. So again we have got 2 edges. Similarly these 2 edges are meeting over this particular end. So 3, 4, 5, 6, 7, 8, 9 and 1, 10, 11 and 12. So in total you will see that a cuboid has got 12 edges. Okay. Now the point where the 2 edges meet each other, it is called the vertex. So all the corners that you see in a figure, here this is the corner. Every corner that you see, it is the vertex. So we can just write corner, and this corner is termed as vertex. Now let's see how many vertices are there in this particular figure. So 1, 2, 3, 4 at the top, 1, 2, 3, 4 at the bottom. So total we have got 8 vertices in a cuboid. Now I hope you have got an idea what faces, edges and vertices are. Let us learn about the faces, vertices and edges of few more 3D shapes. So starting here we are going to write the number of faces, edges and vertices, and starting with cube. Cube is a cuboid which is having all the faces of equal size. The sides of a cube are all equal. So it is a special case of cuboid. So it will have everything similar to what we have just discussed as in a cuboid. So how many faces do you see? We have got a total number of 6 faces, just as we have discussed about a cuboid. Okay, so 1 at the top, 1 at the bottom, then on the sides we have got 2, and then at the back end you will have 1, and here we have got 1 more. So total number of faces we have got 6 in a cube. Now coming to edges. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, and then at the back we'll have 10, 11 and 12. So total we have got 12 edges in a cube. Coming to the number of vertices, that is the number of vertex, the corners that you see in this particular shape. So here we have got a total number of 8 vertices, right? So now moving to cuboid, as we have just said that cube is a special case of cuboid. So all the faces, edges and vertices, they are all similar in cube and cuboid. So see, 6 faces, 12 edges and 8 vertices. Now coming to the cone. As we just discussed, if you make a cutout of a semicircle like this, and if you turn and join these two corners, this and this together, you will see a shape of a cone that has been formed, right? So in a cone, how many faces do we have? Here we have a bottom face. At the bottom, we have got this particular kind of face if we look from down. So this particular face is one face. So, and the other is the curved face. This particular face that you see, which is all curved, so it is also called a face, and in total we will say 2 faces are there in a cube, in a cone, right? Now, how many edges do you see? How many corners? Clearly, the bottom end has got no corners, as it is not made up of any line segment. It's just a single curve. Now, coming to the number of edges in a cone. So, in a cone, the edges that you will see, it's just this one. I'll just use a different color. So the edge that you see is just this one. This is the edge of your cone. So in a cone, you just have a single edge. Now coming to vertices, it has got just a single vertex, just a single corner at the topmost point. So this is the vertex for our cone. Now moving to the next shape. Here we have got a sphere. I hope you know what a sphere is. If you have got a circle, if you imagine a circle in a 3D form like your earth and like sun, like stars, moon, all these are examples of sphere. So in a sphere, the number of faces that we have got just one single face. The complete face is seen as a single face. We don't have any of the curve, the vertex. We don't have any in a sphere. So it has got just a single face. Now talking about the edges. So this is wrong. It should be 0 edges. A sphere, it has got 0 edges. We don't have any line segment meeting at any point. So it has got 0. 0. I'll just write it here. So these are the faces. These are the edges. And these are the vertices. Okay. So faces, we see that there's just a single face. It has got no edge. It has got no vertex. We don't see any corner in a sphere, right? Now moving to cylinder. A cylinder has got a total number of 3 faces. Here on both the ends you will see 2 faces that are circular faces and one complete face that you see here. The complete that is making a rotation. This complete is another face of this cylinder. So in total we have got 3 faces. Now coming to the number of edges. So I hope you remember that in a cone we observe that here where we see the sphere, this particular, not sphere, the circular plate, this particular circular plate is making edges with this rotating face. So here we see that this is a edge of our cylinder. So one face is here and the similar kind of face you will see on the other end. So this is also the other edge, right? So both the faces has got their edges. So in total we have got 2 edges and we have got 3 faces. Now the number of vertices. Do you see there's any corner here? We don't have any sharp corners in a cylinder. So we will say 0 vertices. Okay. Now coming to the next image. It is a square based pyramid. So we just discussed about pyramids. We usually name pyramids depending upon the face, that is the bottom face. So whatever shape that we see at the bottom, we name the pyramid according to that shape. For example, this particular shape that you are looking at, it is a square based pyramid. If you see the base of this particular pyramid, it's like a square, okay, with the bottom, I'll just draw it here, with the bottom end of a square, it is standing on top of it. So this is a square based pyramid. Similarly, you can also have a pentagon as a base face for a pyramid. So if say this is the base and we see all these walls meeting at this point, so this is a pentagon based pyramid. So pyramid can have different names depending upon what base they are standing at. Okay, so here discussing about the square based pyramid, how many faces do we have? All these triangular faces will also be counted. So clearly we can see two faces at the front here, one. So I'll just draw it again and then we'll confirm how many faces. So one at the bottom, then two, then three, 4 and 5. Oh, so this is again wrong. It has got 5 faces. So a square based pyramid has got 5 faces. Now the number of edges it has got. So 1, 2, 3 and 4, 4 edges for the bottom face, and then for the triangular walls 1, 2, 3 and 4. So total number of 8 edges are there in a square based pyramid. Now the vertices. So clearly 4 vertices we can see at the bottom face and 1 at the top. So total are 5 vertices. I hope this is clear how we are required to calculate the faces, the edges, the vertices. Now let's read another figure. Here this image is an image of a prism. Now what is a prism? Prism is like a face where you see, like here it is a triangular prism. So here we have got the triangular faces on either ends and then we join it. Okay. Now if you see this cuboid here, this shape, it is a cuboid. However, they have written its name as rectangular prism. Why? Because here the two faces that you see, they are rectangular and we are just joining it all. So a prism is like a shape which can have different names depending upon what kind of face that the two opposite faces that it holds. Depending upon that, we change its name. Like here we just see this is a triangular prism, this is a rectangular prism. If suppose you have got a pentagon, so say this is a pentagon here and we have got another pentagon here. So suppose these are the two faces and I'm joining these faces, right? So I'm just trying to make a rough figure, really bad one. Okay, so this kind of a structure, if you see, this is an example of a pentagon prism. Okay, I hope you remember that prism is nothing but when two faces, the opposite faces, they are joined together. What we get after joining them, we call it a prism and we name it depending upon those opposite faces. So starting with this one, the triangular prism, let's see how many we have. This is the faces, this one is edges, and this is vertices, right? So here let's see how many faces we have got in triangular prism. So one face here for the triangle, similar face here for the triangle, and then we can clearly see one is over here, one at the back and one at the bottom, and one, so like two faces on either sides and one at the bottom. So 3 total faces from between and 2 faces from the sides, total making 5 faces. Now coming to edges, that is the line segments we see. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see total 9 edges in a triangular prism. Now talking about the vertices, that is just we need to see how many corners are there in total. So we see that the triangle has got 1, 2, 3, 4, 5, 6 corners. So this particular shape, triangular prism, has got 6 vertices. Moving ahead with rectangular prism. So rectangular prism has got again 6 faces, 2 on either ends here, and 1, 2, 3, 4. 4 at all the ends, right? So it has got total of 6 faces. Now coming to the edges. So here 1, 2, 3, 4, 5, 6, 7 and 8. These are the two faces that we have just calculated. Now the other ones, 1, 2, 3 and 1 will be exactly sitting here at the back. So it has got total of 12. So 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, 12. So 12 is the total number of edges in a rectangular prism. Now coming to the vertices. So count down all these corners. So 4 from each of these rectangular faces. So a total of 8 vertices are seen in a rectangular prism. I hope now you're clear how we are going to calculate the faces, edges and vertices of a given shape. Now let's look at this image and let's try to find them on us. Okay, so a triangular pyramid has a triangle as its base. It is also known as a tetrahedron. So here comes the word tetrahedron. This is the name which is given to a triangular pyramid. Okay, I hope you do remember what is a pyramid. When the pyramid that we just learned about was a square based pyramid, where at the bottom we had a square and all the edges, they were meeting together at this particular point. We gave this particular type of pyramid as square pyramid, square based pyramid, and this that we are going to discuss now here, this is a triangular based pyramid. So now a triangular based pyramid has got triangle as the base. So this brown colored face, this is the triangular base. Now let's count all the faces that we have. So 1, that's the bottom face, 2 over here, 3 over here, and 1 will be exactly at the back side. So we see total number of 4 faces. Is that right? Now let's count all the edges. If you want, you can draw it again. So this is the base, that is a triangle. We all need to make it meet at this point. So 1, 2 and 3. Okay, sorry for my bad drawing. However, this is something like it will look like. So here clearly we see that we have 1, 2, 3 and 4 faces. Let's see how many edges we have drawn. So 3 for the bottom one, 1, 2, 3 and 1, 2 and 3 for the edges. So total number we have got is 6. Moving on to corners. How many corners do we see? So 1, 2, 3 for the bottom face and 1 at the top where all the walls are meeting. So in total we see that a corner has the number of corners in a tetrahedron are 4. Okay, is that clear? Total we have got 4 corners in a tetrahedron. Now moving ahead here. This here is a square pyramid and it has a square as its base. Clearly this is a good image where you can see clearly what number of faces are there, how many edges, how many corners. So let's count them down, starting with the number of faces. So here comes the first one at the bottom, 1, then 2, then 3, then here at the front that we have 4 and 1 at the back we have got is 5. So how many total faces we have got? We have got 5 faces. Now see how many edges do we have? So 1, 2, 3 and 4 at the bottom. 1, 2, 3 and 4 at the triangular walls. So in total we have got 8 edges in a square based pyramid. Now let's count the number of corners. So 1, 2, 3, 4 and 5. So total number of corners in a square based pyramid is 5. I hope this is right. Now let's see the last one here. It says a triangular prism looks like a shape of a kaleidoscope. A kaleidoscope is an instrument. If you keep a particular kaleidoscope in front of a ray of light coming into it, it will show you a rainbow coming out of it. So this particular prism is used to see a single light ray breaking down into 7 colors of your rainbow. Okay, so this is kind of a science experiment. You might learn it soon in your class. So here what we are going to see is that the triangular prism, it looks like the shape of a kaleidoscope. It has got a triangular base. So the side face that you see, we call them the base of this prism. Okay. And as we just discussed that the prism, it is named according to the side faces, the 2 sides that we have. We name a given prism according to that. So how many faces do we have? 2 faces here and there, and 3 faces over if we go round this particular surface. So total number of faces are 5. Now the number of edges. So the line segments basically 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total number of edges are 9. Now let's count down all the number of corners that we have here. So 1, 2, 3, 4, 5 and 6. So the total number of corners that we see in a triangular prism, which looks like a kaleidoscope, is 6. Right? I hope you have understood well about these 3D shapes and you are well confident how to find out the number of faces, how to count the number of edges and corners in these shapes.